Lists contain other values. They're values that represent collections of other values. And when you have one value that contains another, you might ask the question, does an element appear in a list? There are actually built-in operators for testing whether an element appears in a compound value, such as a container. So let's say I have digits, which is 1, 8, 2, and 8. I can ask, is 1 in digits? Python will return true. So in is an operator that evaluates both 1 and digits and then determines whether 1 appears in digits. 8 is in digits. The fact that it's in there twice doesn't matter. It's in there. 5 is not in digits. So if I said 5 in digits, I'd get false, but since I said 5 not in digits, this is another operator that's equivalent to saying not 5 in digits. Let's look at a few other examples. So here's digits. 1 in digits is true. 5 in digits is false. Now, it has to be the value. Since 1 doesn't equal 1, if I say 1 in digits, the string 1 is not there, only the integer. Also, we're looking for an individual element. If I say, is the sequence 1, 8 in digits? It says false. But there it is, 1 and 8. That's not what the in operator does. It doesn't look for subsequences. Instead, it looks for individual elements. If I had said, is 1, 2 in the nested list that contains 1 and 2, that would be true, because there it is right there as an element of this list. But if it's nested too deeply, then it's not there anymore. So this is a simple operator that doesn't search through a structure trying to find anything that matches. Instead, it just goes element by element and sees whether it's equal to the element that you're looking for.